Please welcome to the stage Jeff Otto with Riskified.
Just take those old records off the shelf. I sit and listen to them by myself.
Thank you so much for being here with us. We really appreciate it. I get the fun job of talking about an arms race that's happening right now between the good and the bad, and it's a little bit of a different risky business than that old Tom Cruise movie. We're going to talk about this here today, and it's kind of interesting because you think about what we're doing as technologists, as fraud teams, as merchants to protect the shop, and using new advanced artificial intelligence tools to do so. It's quite exciting. But on the other side, on the dark side of this equation, we've got some bad AI. We've got some, let's get the devil horns on there. It's generative AI being used for nefarious purposes, new tools, massive fraud communities that are growing. We're going to talk about all that today. So I'm going to be joined in a few minutes by Alexander Hall. He and I, we're going to talk about the dark side, but don't worry, it's not all doom and gloom. My wonderful colleague, Hilla, is going to come up and she's going to talk to you about what we're doing to protect all of your businesses. So, digging into it, as a CMO, what I often wake up thinking about is all of you, merchants in the room. What pain are you feeling? What problems are you trying to solve? And then how can we help? Well, the fun part about today is we actually got to take a look into the mind of the spectrum of fraudsters. And popular culture has made this interesting, right? If you've seen, Jason Statham's got a new blockbuster movie, The Beekeeper, where, entire contact centers of fraudsters are, calling on grandma and spear phishing her out of her life savings. Or, if you like Mr. Robot, I think Rami Malek is the fraudster professional persona, right? Hoodie, down in the basement, 5 screens, coding Python, hacking the Pentagon or whatever he's doing, right? And I'll be honest, what we're seeing in the data is that, that is not the large population that we're dealing with here today. The large population is not that sophisticated. They're more on the left side of the screen. The opportunistic scammers, the newbie experimenters that, maybe don't have any moral qualms about sticking it to a corporation or a merchant, right, and stealing from you. And so, at Riskified, what we invest in, and you saw a little bit of Danielle's amazing merchant health team and what they do. In addition, we have risk intelligence teams that are scouring not just the dark web, but also the clear web, and surfacing patterns as we watch this threat landscape evolve. And so my amazing team that does this work shared with me a few practical examples. You kind of saw from Danielle earlier, all right, here's what we're seeing on our side of the shop. Now let's walk into the shoes of a newbie fraudster who's setting up Fraud Incorporated, right, their little small business shop, and let's see what kind of tools are available to them to get that job done. And it's going to be in 3 steps, very simply. We're going to acquire some stolen credit cards, not on the dark web, on the clear web. Type in a URL, go to a nice marketplace, buy some stolen credit cards. Second, we're going to use new generative AI tools that have been cracked and trained for fraudsters, and we're going to learn how to buy fensible goods at scale. And then finally, we're going to sell those stolen goods on Telegram. So let's start here. What you're seeing on your screen is one of those bazaars, one of those marketplaces. They have fun names like Knolled and Cracked and Blue Ocean. This one's called Fox Store. And for those of you in the back, what you are seeing here is somebody perusing this like they would any e-commerce marketplace, and they're filtering and they're looking at, all right, I want to see the accounts that have all the loyalty points in there, the Marriott accounts or the Southwest, right, accounts, or which ones have credit card details that were, when the account was compromised, the credit card details are stored in there. And you can very easily select, put in your shopping cart, and buy at scale all of these stolen credit cards. The next thing, this is WormGPT. Pascal mentioned it. We were actually talking about it yesterday in our customer advisory board meeting. There's a couple flavors of this. There's FraudGPT, there's WolfGPT. They actually have a little bit of competition on their pricing. Prices keep going down on these things. But basically, it's a cracked large language model. It's a cracked version of OpenAI's ChatGPT, except it's trained, so you can prompt it to ask questions and learn fraudster PhD stuff. So you can ask it things like, hey, can you code for me in Python a bot that will go and test the 1,000 stolen credit cards that I just got off of Fox Store and see which ones have been shut off by the issuer or not, which ones are still valid that I can use. Or I can say, hey, can you code me a bot? I want to hit Nike.com a couple thousand times and get the new Air Jordan 16s, right? And it's not just, it's giving you the code, right? And also instructions for how to implement that code. I mean, you don't need to be technical to use a lot of this. Whereas back in the day, maybe the Rami Malek, Mr. Robot, had to learn all this stuff. Now you're being taught. You can go to night school with WormGPT and learn this. And finally, let's talk about Telegram. All right, Telegram started by the two Russian brothers about 10 years ago, and, as a private, encrypted messaging application. Now it's got 200 million daily active users, over 1 billion downloads. Now granted, a lot of those folks, they're using it just for private conversations. However, there's a lot of people that are using it for some other stuff. For example, here is, call it some legitimate, some gray market, and some black market high-end sneakers, like those Air Jordan 16s, being sold on a Telegram channel. And there are hundreds of these channels that our team monitors. They pop up all the time. Here's some of the growth that we've seen in the last 10 years for these tools, these communities, et cetera, that are powering kind of this next generation of fraudsters, right? You see the growth, obviously crypto, right? Crypto exchange and the, what that provides to fraudsters. You see the Telegram growth in phenomenal growth over the last 10 years. And then, even Discord, Tor's got about 2 million DAUs. And then WormGPT, we just hit the market a couple years ago, has got 5,000 paying subscribers. They're paying €300 a pop to have access to it. And as those prices come down, more people are going to buy. We don't know what the latest subscription levels are. So, back to the spectrum to reorient you. Now think about this. It used to be the economic curve for the Mr. Robot professional fraudster was, I need to learn all of that experience and put a lot of time and effort in order for me to climb this curve and get an ROI out of it, right? Now, with these tools, we've seen the effort drop, information barriers have dropped, tools are more sophisticated, the training capabilities are more sophisticated, and now it's just a lot higher ROI, to spend fewer hours doing this stuff. You saw Shahar mention this earlier today. Even socks are not a safe segment anymore, right? This is an actual example from our merchant network of somebody that took the time to go attack socks at one of our merchants, right? So, in aggregate, the problem continues, and we see through the clearest data set available, card-not-present fraud data, and predictions by Data Insights, and also our partners at Ethica, that this is going to continue to grow, and we're looking at a 13% compound annual growth rate in card-not-present fraud, even some growth in Europe. So, what I'm excited to talk about next with Alexander Hall. Alexander, first of all, is founder of Dispute Defense Consulting, and he wasn't just someone like all of us who learned about fraud. No, he actually committed fraud. He was a fraudster, practicing fraudster, and is now reformed, white hat, and is consulting to try to help merchants stop the former version of him. And so I'd like to welcome to the stage Alexander Hall. Oh, thanks for being here. I've really enjoyed our conversations the last couple of days as we get into this. Well, first, tell us just a little bit of your story, because I find it fascinating, kind of how you started and then how you flipped to the good side.
Sure. So it all started a good while ago, 17 years ago. It really started with me partying, making bad decisions already. Through partying, I learned that there's a quicker way to make money. I can make money from behind a screen, going up to an ATM, or going in store and doing different things. Much less risky than doing things like drugs and all that part of the lifestyle. So what I did during that time was I started to learn from other people in my network credit card fraud, check fraud, different ways to leverage identity information. Now, at the time, I identified that the people I was dealing with were very unintelligent people. So I would take a bit over here, and a bit over here, and a bit over here, and I would see the through lines. And then from there, I would start to go look at different platforms, see where I was able to engage, reverse engineer verification processes, and build and build and build. And that's where I lived for about 10 years until my daughter was born, and I realized I have something to lose. So I changed my life, and now I work with all of you guys, training teams, building, refining fraud strategies, and helping however I can.
Nice. That's great. We're glad to have you on our side now. We were talking about, you have this model in your mind that you think about different kind of fraud patterns and complexity. Can you talk to us a bit about those 3 layers as you see it?
Sure. So I see there's 3 categories. There's one called linear, there's one called multi-touch, and there's one called multi-system. So let's look at linear. When a fraudster gets compromised payment information or compromised information, they're going to take it, they're going to copy and paste it into whatever form it fits into. So for me, I look at it as payment information is going to go to the merchant, identity information is going to go over to a financial institution, and then login details are going to bridge that gap. So that's linear, copy, paste. Pretty straightforward. Think about payment fraud, think about check fraud, think about the ATO aspect, think about social engineering. One touch point, I submit information, and I get what I want. When we move over to multi-touch, that's all-inclusive on one platform, but it requires multiple touches in order to monetize the attack. So think about ATOs. Someone might call into customer service, they might satisfy knowledge-based verification questions, they might reset access on the account, then they log into the account. Well, simply logging into the account isn't valuable. You still have to do something to get something out of it. So then they add an authorized user, they send out a secondary card, then they transact. All of that visibility, well, if you're a financial institution in that case, all that visibility is on the platform. For merchants, it might be associating a new payment method, going through the checkout process. It's pretty straightforward, but all of the visibility is on that platform. So that's multi-touch across one platform. When it comes to multi-system, that's where things get tricky, because consider that the visibility is split between multiple systems. So one example of that might be, one thing that I call third-party ATOs, where I'd find an established account that I was seeking to exploit. I'd go over to some fintech platform. I would link the 2 accounts by verifying the microdeposits, and then I would use the fintech account for payment to the merchants. Think about the visibility there. Who has the visibility to see this happening? Everyone only gets one part of the puzzle, and everything looks good depending on where you look. So that's what multi-system exploit is.
It sounds like that's almost the foundation to building synthetic identities.
Yeah, so synthetic identities, if you think about it, in order to associate, okay, so first let's define synthetic IDs. A disparate date of birth, social security number, and name, and address, whatever, are being brought together. But that relationship is being built by making the relationship happen at different systems. So for example, what I used to do is I'd go to Guitar Center, and I'd order a catalog. And I would use a real name, I'd use a real email address, but then I'd put a shipping address or an address that I want associated with that core identity. I would associate that, and that's where I'd have the catalog shipped. Then I'd go over to someone and I'd order a newsletter that goes through email. So now I've just injected the email. Then I'd go somewhere else and I'd ask for some cell phone update, whatever. And now I've just associated a cell phone number. That is what synthetics are. Now, where I lived was one step above that, what some vendors are calling, well, it's a trademark name, so I won't say it here. But where I lived was what I consider to be real identity theft, where instead of having disparate identity elements, I used a real compromised identity, and then did the superficial network relationship building, and that led to where I lived for like 5 years.
Yeah. Now, what did you think about some of the tools? You know, you and I we were talking about, WormGPT, and we were talking about some of the communities of fraudsters and their growth. What are you seeing from your vantage point?
I think that what all of all of the new technology in the hands of a fraudster is serving 2 points. One, they are meeting the requests that our platforms are making of them. I specialized in building what I liken to a Trojan horse. So if I get compromised information, I'll go to these different systems and make it look however I want before submitting it to a target platform. That Trojan horse element exists Every time we tell someone to jump through this hoop, submit this form, meet our questions, answer our questions, submit your KBVs and all this different stuff, that's effectively setting the fraudster up to submit the Trojan horse. So that's one, fraudsters are meeting our requests. And if we look back over the last 30 years, we saw everything from account creation to logins to checkout, and now we have voice biometrics, facial biometrics. They're just meeting the requests that we give them. So it's easy for them to reverse engineer. Now, I will tell you, I'm shocked about how short that time was for them to be able to do it, but it should have been expected. If we request it of them, they will provide it. So that's one. And then the second part's pretty simple. With automation, they're able to automate. So like I was saying earlier about ordering a catalog or signing up for a newsletter, well, now they don't have to actually go do that 45 seconds of work. And as Danielle was saying earlier, they can do it 100,000 times in 30 minutes. So that's what I see of how it's being leveraged.
Yeah, interesting. All right, so I want to pretend, we've got a time machine here. We're taking the dark side Alex from 10 years ago, and we're putting him in that time, so we're bringing him forward. What advice do you have for the merchants here to beat the old you? How do they defeat you?
Stop letting me know what you're verifying. Don't tell me that you didn't pass this part of the test. Don't ask me questions. And for that, move into passive data sets for your determinations. That's one. So passive data sets altogether should be considered behavioral. And I think it was Danielle earlier on the slide who was pointing out the connections between different data points. The problem is all of those data points look fine on their own, which leads me to the second step. Passive data sets, and then the ability to read the story of the relationship and the linkages between data points is going to be paramount in a fight against me. So yes, passive data sets, and seeing the story of the data. What I call, when in my trainings, I call it see more than you are shown. So when you see 10 data points that look good, read the data. Someone should not have 5 billing addresses. Someone should not have 5 shipping addresses all linked in the last 2 weeks. Even though every individual data point's good, we should be equipped to read the data and say, something suspicious is going on there. I think those are the 2 things that I would recommend.
Fantastic. Alexander, thank you so much for doing this with us today. Let's give a warm round of applause for Alexander.
Thank you, everybody.
Thank you. All right, now I am blessed to get to work with this individual, Hilla Peled, who leads our amazing data science team. Let's give her a warm welcome. She's going to talk about how she's protecting all of us.
I'm gonna fight 'em all. I said the nation army couldn't hold me back.
From year to year, Jeff is making it harder for me to get on stage. And I'm going to start again saying I'm going to apologize if I move into Hebrew throughout my session. I'm very excited being here and talking to you guys. So first of all, thank you, Jeff. And Alex for letting me be the good cop here, because you obviously scared the audience, my mom included. So I want to start by saying it's not as scary as it sounds. I know, and in the next 10 minutes, my sole purpose is to give you the same confidence I have that AI power can work on our behalf, not just against us, as just was suggested. But before I start, let me stop for a minute. And I have to address, standing here on stage, the elephant in the room. So what the heck is going on with the AI hype and the buzzwords all over the place? Now, don't get me wrong. Being a data scientist these days, I feel almost as important as the President of the United States. But it is very important to understand what is applicable to real-life problems and what is just very great publicity. So if you've been around in the 5 to 15 years in the data space, you probably heard these words. Very amazing concepts, incredible evolution. And I'm going to say that again, evolution, not revolution. I know that some of you may think, how dare she address ChatGPT as evolution and not revolution, but I'm going to do so and tell you that large language models are a great evolution of language models. And let me take you back to 1950. It was when Turing decided to create an evaluation where a human will evaluate a natural language conversation in between a human and a machine that was designed to create a human-like responses, also called the imitation game. That is when language models were first introduced, even prior to that, but then it was coined. It was in 1970, so many years ago, when Eliza, the first chatbot, was introduced into the space, also called the doctor. Eliza is a therapist-like chatbot, reflects back on the patient's questions, trying to resemble to a therapist session. So yesterday my therapist was not available. I tried it myself, and you can see the example. Just keep in mind and let that sink. This is more than 50 years ago. By the way, she didn't confirm already best. I'll let you know afterwards how it went. So going back to 1997, recommendation systems. What is that technology? Think of the way you navigate your everyday lives these days. If it's Netflix, where you watch TV shows that are recommended to you, if it's Spotify, where you barely even choose the music you hear, but it generates your entire list, or if it's Uber, your preferences. These recommendation systems existed a while ago. It was in 1997 that the Deep Blue machine won for the first time a chess game against a human, then called by IBM on a supercomputer. And in 2010, 2020, everyone knows about the big data hype. If you didn't have big data, you weren't someone. So this is where we had a pivot point where we had to address vast amounts of data due to the internet world. And we had to address unstructured data in these vast amounts. It was then when we built systems that are able to compute and process large amounts of data and unstructured. And that what allowed the last 10 years to evolve in such a fast pace into much larger processing of data that resulted in what we call today deep learning, and I'm going to talk about that later, what used to be machine learning, old news. And what we know today, here comes the bride, ChatGPT, large language models. Again, language models existed. ChatGPT was able, or what we call OpenAI was able to create ChatGPT or Lambda in we were able to digest very large amounts of data, getting the sense that there's someone, a person, know-all behind the screen, when it's actually just large amounts being digested into natural language processing. So let me pause here for a second. We already formalized the fact it's not new. Let's talk about the scary part. My friends here, who did a very good job to scare you, have already proved that AI can be leveraged against us. But what I'm here to tell you, and also demonstrate with 3 examples, is that AI can also be a very powerful tool to fight against AI. And this is where we're currently at. We always are able to identify and we can predict what fraud and behavior will look like. So let's go back to Jeff's example. We were talking about prompt WormGPT. We're all scared about GPT, that codes a bot. And we know that if a fraudster was able to do something in the past, in a given time, now a bot can do that thousands times more, right? But what I can also tell you is that we have systems, and the world has systems today that are highly scaled, we're going to talk about what that means, that can actually identify the trademarks that bots leaves behind, as well as fraudsters. So how do you do that? Before diving into the actual examples of different MOs, what I am going to double click on is fraudsters and bots change behavior very frequently. Data changes all the time. Every loophole that you have, the fraudster will find. Once you close it, he'll find another one. What we need to build is systems that are capable to quickly adapt and scale to these ever-changing trends. So allow me to introduce you the AI Engine 2.0, what we call the autonomous driver. In essence, we have our models training, we have our engine, we created an AI layer on top of that that removes the data scientist from the equation. And before I'm going to explain how that works, I'm going to talk about the business value. Like we Israelis love, what's in it for me? So without autonomous training, it's 1 to 2 weeks of data scientists to train the model, to decide on the data sets. With autonomous training, you only need 3 to 4 days to train a model and quickly adapt to any new attack that Alexander or any of other fraudsters in the past had ever had. Without autonomous training, you can create 40 to 60 different variations of models. You need to run against different data sets, different time frames. But when you have a computer running the model training itself and the different inputs into it, you can create hundreds of different variations that will then result in much better performance. So what does that look like? If we think about how model training happens today, probably in your companies as well, then a data scientist will sit in front of his computer and will need to decide all kinds of questions. For example, what sampling method should I use? What size of data set? On which dates should I choose the data set for the data quality and sampling? After multiple manipulations, he'll choose the right, correct answer. Then he will have to create another input for features creation and selection. What new fraud MOs do I have? Which features should I choose? And what new data patterns do I see? All of that being created by your data scientist, although model training is today automatic, being fed into the model training. With autonomous, what we have is boom, boom, boom. The machine itself can create all the different variations and feed the right input and the optimized one into the engine. What's in it for me? Less manual effort for data scientists. You probably care less about that. More value to get into the data science state working on the actual performance. Better performance due to much more variations and faster time to production. This is an example just how we build a system that allows us to address the fast pace and the accelerated environment we have today. But now let's talk about the problem itself. So we talked about a fraudulent online purchase being made, and we talked about AI that has to be the good. My mom always told me the good wins the evil. So let's see an example of an order. So this WormGPT customer has decided to place an order, and when you look at the shipping address, it just seems like he has a minor typo in his address. And Alexander also referenced that. But what we learn is that this minor typo is actually a way to obfuscate the address. Why would he obfuscate his address? Because then he can create multiple orders for the same address. It can create different fraudulent orders with hundreds of IPs and hundreds of different emails, making sure that the mailman will know exactly where to ship the product. So what's the solution? The solution is A, use NLP in order to clean and understand what the actual address is. This is one example. Interesting examples could be Paragona. The mailman will know it's Tarragona. He will think that the person just accidentally had a typo, and here you go, you have a fraudulent order placed. But that's not enough. Knowing the address will not help me understand who's the person behind the scenes. What will help me understand is to match this address against a large amount of 12 years of data, your data, merchants. And what I'm able to do is run a similarity algorithm, deciding from all the different identities I have within my network, who is the address most similar to. And then I'm able to know that that WormGPT was actually in my database also as Barney Smooth and also as Chaka Rock. And now I have his entire behavior pattern identified and able to decide whether his behavior is fraudulent, not just based on that single order, but I'm actually able to have that match. One last example you gotta get from me. is going to talk about the products. Alexander said something interesting about reverse engineering. I think the one thing that is great about deep learning is that no one really understands it, so you'll never be able to reverse engineer it. Why am I saying that? Because when you think of products and when you're looking at the sample of products we have here, Easy Boots, one could argue that there's nothing fraudulent here. Seems completely legit. What we learned in many of our industries is the product titles are more prone to be fraudulent, but just very specific product titles. What we did is we understood that machine learning doesn't help in this case. Let's pause for a second and talk about machine learning versus deep learning. Machine learning, you get an input, you have an output. The machine tries to understand the patterns in between the two. Deep learning, you have the same, just many more layers. What does that mean? Deep learning neural network mimics a human brain neural network, trying to have that exact behavior of much more complex patterns and connections. Computer vision is a good example for that. So what we realized is that machine learning didn't help us to have that information, and we moved into deep learning. What did that bring us? Because we don't care about the technology, we more care about the results, is that if you look at these product titles, the risk score each product title has varies significantly. While they seem completely similar, they're actually different. And what I can learn, and I could not learn using this, and cannot be reversed engineered, is that these products are very likely to be fraudulent, and that allows me to decline such an order in real time based on that information. So before I give the stage back to Jeff, I'm going to ask you to remember two things from my session. One, it's not new, great evolution. AI power can work on our behalf. Two, I was the good cop.